Okay, I'm just going to recap the different tests here and why they work. So first, we'll look at the first derivative test. So what we do is we take the first derivative and we set it equal to 0, and this gives us what we call our critical points. Now there's a couple options that can happen here. Okay, the first thing is that it could be the case. So let's call this graph f, and then right below it I'm going to graph f prime. Okay, so one option is that when let me just draw out like this. Okay, one option is when we take the first derivative, okay, we find a critical point, and we set it equal to 0. We find a critical point at a maximum, local max. Now the reason for this, for setting the derivative equal to 0, is at the top of a maximum, the tangent line is flat. Now, here's where we have to be careful. Okay. Just because the derivative set equal to 0 gives us a flat tangent line doesn't necessarily mean that we have a min or a max. We could possibly have something that looks like this, where right here the rate of change is flat as well. So we could be at an inflection point, so we have to be careful. Well, how do we know the difference? Well, if it's the case that on the left side and the right side, the derivative itself is a different sign. So here the derivative is 0. So if we're either below, like this, or we're like below to above or above to below, then that shows us that our tangent lines are changing from negative to positive or positive to negative, which means that our tangent lines are going from positive to negative in this case, or if we're at like a bottom here, okay, then on this case, so this one right here, let me draw it accurately. This one right here, the derivative's positive, then we go to negative, so positive down to negative. Okay. On this guy over here, we're going from a negative slope to a positive slope. So we cross through like that. Now, if it's an inflection point, okay, so let's say there's a nice, let's say our graph does something, I hate to erase that. Let me draw another example over here. Let's say my graph goes like this. Okay, if that's the case, then although the tangent line is 0 here, we're going from positive to positive. So what happens is the derivative looks like that. Okay, so what do we do? Well, how do we know the difference between these? Well, that's where the second derivative test comes in. And so what the second derivative test says is that if the second derivative is 0, then your first derivative must be one of these guys right here. Because if it wasn't 0, the slope, now we're looking at the slope of the tangent line. The slope of the tangent line here is negative. The slope of the tangent line here is positive. So right here, f double prime is negative. Right here, f double prime is positive. This is the only case where f double prime is 0. Okay, so if f double prime is greater than 0, if it's positive, then you're at a min. If f double prime is negative, like here, then you're at a local max. If f double prime is 0, oops, I wrote that in there, then you're at an inflection point, possibly. Okay. So how do you know if this guy's an inflection point or not? Well, what we need to do now is we need to take a look at what would the second derivative of this guy, what would the derivative of the second derivative look like? So what would the third derivative look like? Well, the derivative, if this right here is the graph of f prime, then f double prime for this guy at this point, okay, should change from positive to negative. Okay, so f double prime, first of all, f double prime is 0, okay, but it's the change in f double prime, okay, so the change in the slope of the tangent line is going from negative to positive, so there's change there. So if this guy is positive, or if the rate of change of the second derivative is negative, or excuse me, of the third derivative is negative, then that's a situation in which f double prime, okay, f double prime is changing directions, okay? So that means that the following is true. Okay, so this gives us the following. First, if one of these two cases is true and this is true right here, then we have a point of inflection. In situations where f double prime is positive, if the second derivative is positive, that means that the slope, if f double prime is positive, that means that the slope is increasing, so it's pulling like this, which means our concavity is up. We have upward concavity. If f double prime is negative, it means we're at a max, and our concavity then is down. So we can test concavity here, we can test for inflection points, and we can test all of our critical points for minimums and maximums.